Hi, this is Dr. Shaw.
And Monster Puppet.
And we're, oh my God, that's even worse than the other one.
Baseball hats do not suit this man.
Okay, anyway. Last time we figured out a function called a of x. So given any function f of t, it has associated with it a of x. A of x is the area under our function f between 0 and x. The way we can write that is the integral from 0 to x of f of t dt. What we're going to do now is find out the derivative of a of x.
What the hell, man? Why?
Because it's going to give us a good result. We're going to learn something.
Oh, gosh. This guy take the derivative of anything. It's your birthday. Here's some chocolate cake. Oh, can I differentiate it?
No. Okay, well, just let me do this.
All right. We'll let him do it. I know who has the hand up whose butt.
Remember, the derivative of a function is the limit as h approaches 0 of f of x plus h minus f of x over h. Gosh, we did that to death a while ago. So, I want the limit as h goes to 0 of a of x plus h minus a of x all divided by h. Or, using our notation for a of x as the area under the curve f, it's going to be the integral from 0 to x plus h of f of t dt minus the integral from 0 to x of f of t dt, all divided by h. Now, if you look at the numerator, we can actually calculate that. I know it doesn't look like it, but we can. So you see here that the integral from 0 to x plus h is the area under the curve from 0 to x plus that little bit. And we're subtracting the integral from 0 to x, and all we're left is that little bitty strip.
That almost looks like a rectangle.
It does, Monster Puppet. It absolutely does. So we want the area of that little rectangle. Well, the width...
I got this one. It's h.
Yes, the width is just h. Now for the height, we can, if we use the left-hand approximation, the height would be f of x. If we use the right-hand approximation, it's f of x plus h. But we're letting h go to 0. So it's not going to matter. As h goes to 0, those things get closer together. So I'm going to use like f of x because it's easier. So our limit becomes the limit as h approaches 0 of h f of x, h is the width, f of x is the height, divided by h. And the h's cancel. So we're just left with f of x.
Wait, I can't wrap my mind around that. That's too weird. What are you really saying?
I'm saying that the derivative of the area function just goes right back to f. So you take little f of t, find its area function, take the derivative of the area function, and you're back to f again, only now it's f of x. And that's called the Fundamental Theorem of Calculus.
I can't. You got to show me a picture.
Okay. So look, let's go back to f of t equals 3, right? So that's f of t equals 3. The area function is actually 3x. Because as you go from left to right, the area goes up by a factor of 3 every time you move over 1. That's kind of what we were doing when we were plotting points. F of t equals 3. A of x is 3x. Take the derivative of 3x and you're back to 3. We also did f of t equals t. If f of t equals t, the area function looks like this. I didn't go ahead with all the calculations. It turns out to be x squared over 2. And if you take the derivative of x squared over 2, you're back to x. So you can take any function, even a complicated one, find its area function, take the derivative of the area function, and you're back to the original. That's called the Fundamental Theorem of Calculus. Now you know the fundamental theorem of calculus is that the derivative with respect to x of the integral from 0 to x of f of t dt is f of x, which when you see it all like that, it's really kind of but the idea is you take a function, you find its area function, you take the derivative of the area function, you're back to where you started.
Okay, that's cool, but I don't see why it's fundamental. The fundamental theorem of calculus is this little trivia fact for math trivia night at the bar.
So, yes, it has an important use because that's going to allow us to compute the areas of things. It allows us to evaluate definite integrals and get the number. And how do we do that?
We'll find out in the next video.
Yes.
I wonder what hat he'll wear.
Okay.
Will I be in the next video?
If you're good.
Okay.